Hello everyone, my name is Musa Darna and today I'm going to be going over uh, the a couple services and apps that are presented in the Windows and Linux server. Starting off with AppArmor. So AppArmor is a security module that is based in the Linux operating system. It provides mandatory access control functionality. It is designed to enforce security policies for individual applications, and in doing so, it reduces the potential attack surface of an application. All right, some of the features that AppArmor has. It is a profile-based security service. So it has two active modes: complain and enforce. So the complain mode is basically just for logging. It only logs events, and then uh, enforce actually stops those violations. So complain just logs the violations, and enforce actually stops those violations. And in comparison to other security modules, AppArmor is actually easier to use. It provides granular control, so profiles can control access to specific files and directories. Profiles can also be customized to meet uh, specific needs for each application. This is kind of similar to the least privilege principle, which it only allows, so these profiles can be configured in a way so that only the resources each application needs, those profiles can be configured to only allow those resources to those applications. So again, that's another security measure put in place. Um, so web servers, database servers, containers, app farmers can be configured for all of them. Uh, to check the status, if you want to check the status of AppArmor and check how many profiles are running, you can use the command sudo aa-status. And the reason you use sudo is because AppArmor operates at the system level. So in order to, you're gonna need administrator privileges to use that command. So that's why we use sudo in this case. And it's useful for monitoring and troubleshooting. So if you just wanna check the status of AppArmor and see how many profiles are running, it's good for that reason. And some hardening techniques that you can use for AppArmor. So one of them is set all relevant profiles to the enforce mode. So again, this enforce mode is different from the complain mode, which it doesn't just log the events; it actually stops whatever is happening, uh, each violation. And to do this, you can use the aa-enforce command. Another hardening technique would be to create profiles based on the resources needed for each application. Again, this is similar to the least privilege principle. You're only giving access to what is needed for each application. And you can do this by using the aa-generate profile command, or genprof. And the last one is this is probably the easiest one. Uh, Making sure profiles are up to date, and make sure logging is enabled so you can monitor events and see if there's any suspicious activity. Then you can see what's going on. And to do this, you can use the aa-log profile command, or logprof. All right, moving on to HTTPS. A little background about that. It stands for the Hypertext Transfer Protocol Secure. It is used for communication over the web, and it ensures data is encrypted between the user and the server. So this is the secure counterpart to HTTP, which in HTTP the data is sent in plain text. It's not encrypted. So this is the more secure part of HTTP. Some features of HTTPS. Again, so we talked about how it encrypts data. It uses either transport layer security or secure sockets layer to do that. And in doing so, it protects sensitive information. Ensures the identity of the website being accessed is legit through digital certificates issued by trusted certificate authorities. It ensures data integrity, so data isn't being altered or modified through transit. It performs a handshake to establish a secure connection. And so this handshake is, so basically the client will send a message to the server basically saying hello. The server will send another message back saying hello. They establish a handshake, and in doing so, keys. They do an exchange of keys, and after all that, the communication is encrypted. And HTTPS runs on port 4043, while HTTP, which is the insecure counterpart, operates on port 80. Uh, a lot of people, or it's highly recommended that you don't use HTTP since it's it's not secure. Data is transmitted in plain text. This means it's more vulnerable to attacks such as man in the middle and interception. So you don't want that. All right, moving on to Windows IIS, or which stands for Internet Information Services. A little background about this: it is a web server software developed by Microsoft. It provides a platform for hosting and managing websites, applications, and services. It supports many web protocols, including HTTPS or FTPS, and is good for hosting both static and dynamic content. So, static content being content that stays the same, while dynamic is content that is based on user input. So, it's good for hosting both of that. Some features of Windows IIS allows for the hosting of websites and web applications. It includes security features such as secure sockets layer or transport layer security encryption. Uh, it also includes features for improving performance and scalability of web apps, such as caching and load balancing. Caching basically uh, puts data that is and it puts it in a place that is easily retrievable in a cache. So whenever that data is retrieved, it's a lot easier. It's a lot quicker than storing it somewhere else, and it improves speed. And load balancing basically takes internet traffic and puts it on the least busiest server. This just balances out the load between the servers. It's good for scalability and improving performance. It also features a graphical interface, which is the IIS Manager. This is administrators use this to configure and manage web servers and websites, and it also includes logging and diagnostic tools. Some hardening features or techniques for Windows IIS: remove or disable any unnecessary modules. So if it's unnecessary, you don't need it, you should go to the IIS manager, go to the module section and disable it. This just reduces the attack surface. Utilize encryption with secure sockets layer and transport layer security. These encryption settings can be set under the SSL settings in the IIS manager. You can also configure request filtering. So basically, you can block or restrict any unwanted or potentially malicious HTTP requests. It's kind of like a firewall, and then just stay up to date with patches and updates. This is probably the easiest one you can do. Just make sure that your service is staying up to date, and make sure that you're patching it regularly. All right, moving on to Apache HTTP server. A little background about this one: it's an open source web server that's primarily ran on Linux operating system. However, it can also be run on Windows or Mac OS. It's used to serve websites and web applications, and it's known for being highly stable and reliable, which makes it a popular choice for production web servers. Some features about Apache is it's due to since it's an open source software or service, it's very cost effective compared to other ones. It comes with strong security features such as secure sockets layer, transport layer encryption, kind of similar to Windows IIS. It allows for quick patching and updates. Again, this is also due to its open source nature. It can be customized heavily through configuration files, so service settings, access control, error control. Administrators can customize it through files to however they want to. The thing about Apache is it's really customizable, and it's also seen with these modules. So modules can be added to extend the functionality. So again, if there's a specific need for your environment that it doesn't come by default with Apache, you can download modules, and these modules will basically add on separate features to Apache to meet any demands that you need for your environment. So highly customizable. Some hardening techniques for Apache. Disable, kind of similar to Windows IIS. Disable unnecessary modules and features. This will reduce the attack surface. Make sure that encryption is configured, so secure sockets layer, transport layer security, to enable secure connections over HTTPS, or you can also use HSTS, which is basically, if you add this to the header of HTTPS, you can basically automatically configure websites to always use HTTPS to connect. So that's a good one. Implement access control and restrict permissions. And again, regularly update and apply patches. This is probably the easiest one you can do. Just make sure your service is up to date, and this will mitigate any vulnerabilities that come up. And these are my references. And that is the end of this slideshow. Thank you for watching.